When I was a young child, my father built his own telescope. This was when I was still living in South Africa. And I remember my sister and I helped build the concrete for the base of the telescope. And we were so excited. And we looked through the telescope, and the first thing I saw was Saturn and its rings. And I thought I could see some of the moons. I probably couldn't because it was too far away. But then at the back of my mind, I've always been interested in Saturn and its moons, never thinking that I would be fortunate enough to be involved in a spacecraft mission that went to Saturn, and involved in an instrument that took data that helped make a discovery about one of the moons of Saturn. And so the moon in particular that I want to talk about is called Enceladus. It's a very small moon. It's about 500 kilometers in diameter. And people have always wondered about its surface. It's a very young surface. And if you compare the surface of Enceladus to the surface of one of the other moons close by called Mimas, Mimas is covered in lots of craters. And so you would expect Enceladus too to have lots of craters on the surface, but it doesn't. The surface looks really young. The other thing about Enceladus is it's quite close to Saturn in an environment where there's a lot of water vapor molecules. And people have always wondered, could Enceladus somehow be the source of this water vapor? And so before the Cassini spacecraft mission reached Saturn, we had lots of views of Enceladus through telescopes on the ground, but it was so far away you couldn't really tell what was going on. The Voyager spacecraft flew past Saturn in 1979, I think. And as it flew past Saturn, it took an image of the surface of Enceladus, which confirmed the fact that it's very young, aren't any craters. And one of the instruments on board the Voyager spacecraft took an image of the surface in the infrared, and it essentially told us the surface was made up mainly of water ice. And so that's what we knew about Enceladus before Cassini got there. One of the things you need when you're involved in outer planetary missions is lots of patience. It takes years from when you first think of sending a spacecraft to when you at last start getting the actual data back. So we designed and built the instruments in the early 1990s. It was launched in 1997. Took 6.5 years to get there, so we got there in 2004. And then we had our first flyby of Enceladus in 2005. And what we saw in the data was strange. It was almost as if Enceladus was much bigger than we really knew that it was. Because what happens is, if this is Saturn over here and this is the moon Enceladus, Saturn has a magnetic field which orbits around or rotates around at the same rate that Saturn does. And the magnetic field lines, if they pass through a moon, if the moon is a dead body, the field lines of Saturn won't see it. And we expected that. So when we flew past, we saw the magnetic field lines of Saturn coming up towards Enceladus, and instead of moving through Enceladus, they stopped upstream, almost as if it was a bigger obstacle than it should have been. So we had a close look at the data, weren't quite sure what we were seeing. One of our concerns was that as the spacecraft flew past Enceladus, it was moving very quickly so the cameras could point at Enceladus. And we were worried that maybe we weren't resolving the movement of the spacecraft properly. And so we didn't say anything. We thought the data was really interesting. And then a month later, we had a second flyby. And in that second flyby, we saw exactly the same signature. Enceladus was here, and something was stopping the magnetic field penetrating down onto the surface. And in addition to that, what we saw in the magnetic field data was lots of wave activity, which, if you did the calculation, was telling us there was a lot of water group ions being picked up. And so we tried to put a model together to describe what we thought we were seeing. And one way that we could describe the observations was if Enceladus had an atmosphere. Because what happens is the upper regions of the atmosphere, just like on Earth, become ionized by radiation from the sun, and that stops the magnetic field from being able to penetrate. And we were almost certain that's what we were seeing. So what I did is, in the team, we agreed this is what we were seeing. So I went out to the Jet Propulsion Lab to talk to the Cassini project, because what I wanted to do was try and persuade them on a subsequent flyby to go really close to Enceladus to see if we were really seeing something interesting. I wasn't sure if it would work, but I thought it was worth a try. And it was really interesting. We talked for 3 or 4 hours in meetings about whether we should do this. If we did it, it would mean that some of the other instruments, some of the other teams wouldn't be able to take data. But people were clearly excited at the prospect that there might be an atmosphere on one of the moons. Because if there was, that was a real discovery. Because Enceladus is so small, we thought it would have long since died. Any interior heat would have disappeared. And so we finally agreed we would change the next flyby to go really close. So originally we planned to fly 1,000 kilometers above the surface, and the project agreed we would fly 173 kilometers above the surface. And I must confess that 2 or 3 days before that third flyby, I couldn't sleep. Because if we had seen nothing at all, no one would ever have believed anything I said again. But what we saw in the data was spectacular. Instead of there being an atmosphere covering the entire surface, there was a plume of water vapor coming out from the South Pole. And because we went so close, all of the other instruments were able to take data as well. And what we found was that there were cracks at the South Pole. There was not only water vapor leaking out of these cracks, but there was organic material. And the implication was that there was a heat source at Enceladus, which there shouldn't have been, because it should have been cold. Out at Enceladus, temperatures are minus 170 degrees Celsius. How can you have liquid water there? And so we had lots more flybys of Enceladus as a result of this. And in one of the flybys, we measured organic material. And so that's when people got really excited, because one of the reasons we explore the solar system is we want to see if life could form elsewhere. And you need 4 things for life to form. You need liquid water, you need a heat source, you need organic material, and we had all 3 of those at Enceladus. The last thing you need is for those first 3 things to be stable over a long enough period of time that something can actually happen. And so Enceladus is now one of the places in the solar system where we think there is the potential that we don't talk about life, we talk about habitability, that the conditions might be there that life could form at some stage. And so there's now a lot of talk about sending follow-on missions to Enceladus to try and go into orbit, because if you think about it, to be able to understand an environment, you need to spend quite a lot of time there. And so there's a lot of talk about sending future missions to Enceladus, but the problem at Enceladus is that because it's so small, its gravitational field is very small. And so you need a huge amount of fuel to be able to slow down enough to be able to go into orbit. And so that is always going to be a bit of a problem. But I think the discovery of liquid water at Enceladus has now focused people's minds on the fact that if you're searching for liquid water in our solar system, it doesn't have to only be on the surface. You can have environments where you can have liquid water underneath the surfaces. You can be quite far away from the sun and you can still have liquid water form underneath the surfaces. And so that also feeds into people's understanding about exoplanets, so planets beyond our solar system. People have always focused, when they look at these exoplanets, at planets that are close to their parent star. But the Enceladus liquid water discovery has shown that you don't have to be close to the parent star, in our case our sun. You can be really far away, but if the conditions are right, you can actually have liquid water forming under the surface. So I think if I was asked what my favorite moon was, at this stage I would say Enceladus, just because it yields such surprises. We really didn't expect to see this. But the amount of water vapor and the amount of dust and gas that it's been given off is so big that it's actually forming a huge ring of water vapor all the way around Saturn. And when you fly through it, you can actually make measurements of this increase in water vapor. So looking back on the discovery that we made, I think that the main trick was be brave. We weren't sure what we were seeing, but it was clearly something we weren't expecting to see. It was something really interesting. And sometimes you have to just be brave and make a change, and sometimes discoveries are made like that.